The heavy cypress floorboards of Kyoto's Nijo Castle lie in the ambient shadows of the year 1603, waiting in absolute stillness for the pressure of a human foot. When a heavy boot descends, the timber does not merely creak, it screams with the shrill, metallic piercing of a mechanical burr. This is not a flaw in the carpentry or the natural settling of dry wood under the shifting temperatures of the Japanese night, but a weaponized acoustic trap known as the Uguisubari or the Nightingale Floor. Beneath the polished surface, suspended between the heavy load-bearing joists, sits specialized metal clamps holding tension against the wood. Each clamp houses two precise holes, through which an iron spike is driven, creating a friction-based trigger mechanism. When the weight of a human body depresses the floorboard by a mere fraction of an inch, the plank shifts downward, forcing the iron nail to grind violently against the metal jacket of the clamp. The resulting friction produces a high-frequency acoustic wave, a chirping noise designed to echo down the empty corridors and alert the guards of the Tokugawa shogunate. Sentries memorized specific, syncopated walking rhythms to identify themselves in the dark, ensuring that any irregular pressure or hesitant footfall would instantly betray the presence of an intruder. The architecture itself was engineered for paranoia, turning gravity and friction into an inescapable siren. To cross this acoustic minefield required more than mere caution. It demanded a fundamental re-engineering of human biomachines and the absolute manipulation of kinetic energy. The standard human gait is a clumsy, concussive sequence of falling and catching oneself. A contemporary boot with a rigid sole acts as a solid lever, striking the ground heel first and generating a massive transfer of kinetic energy known as the passive impact peak, an event that violently dumps force into the ground in a span of just 5 to 30 milliseconds. This instantaneous shockwave excites the resonant frequencies of the architecture, turning the wooden floor into a vibrating drum skin. To defeat the Nightingale Floor, the Shinobi had to physically dissolve this impact. They utilized a technique called neutralize, the stealthy step, which begins by dropping the body's center of gravity and bending the knees deeply to remove the latent tension of impact from the descent. The weight of the body is shifted entirely to the front leg, transforming it into a silent, load-bearing pillar, while the back leg is pulled forward until the ankles nearly touch. The descending foot does not strike the wood flat, nor does it lead with the heel. Instead, the practitioner places only the extreme outer edge of the foot against the wooden plank. Slowly, the foot rolls lateral to medial, laying flat against the grain in a fluid, continuous motion. This rolling outward edge contact eliminates the vertical impact peak completely, neutralizing the sudden, downward compressive force required to drive the iron nail against the clamp. The biomechanical execution of this movement is biologically impossible in conventional footwear. Western boots and rigid shoes bind the metatarsals together, fusing the digits into a single, blunt instrument and blinding the foot to the tactile reality of the ground. The solution developed in feudal Japan was the split-toe architecture of the Tabi. Originally crafted from single animal hides during the Nara period to accommodate thong-head sandals, like the war-aji or zori, these garments evolved over centuries into highly specialized tools of espionage. By physically separating the hallux, the big toe, from the rest of the digits, the footwear shatters the rigid lever of the human foot. It restores the hallux to its primal biological function as a highly sensitive environmental proband and independent load stabilizer. This bifurcation allows for toe splay, a mechanical expansion where the forefoot spreads upon impact to distribute the body's weight across a vastly larger surface area. When crossing an unstable beam, scaling a wall, or navigating the slanted surfaces of a tiled roof, the independent hallux acts as a prehensile appendage, pinching the surface and feeding high-fidelity proprioception data directly into the central nervous system. The Shinobi could literally feel the microscopic tension of a floorboard, sensing the critical threshold of instability, before fully transferring their body mass into the step. The manipulation of gravity and pressure is only one half of the stealth equation, with the other half being the brutal suppression of acoustic reflection and ambient friction. In 1657, the Great Fire of Miyaki incinerated the vast leather reserves of Edo, forcing a mass industrial transition to woven cotton for the construction of Tabi. This historical accident provided a massive tactical advantage for silent movement. Leather produces a sharp, percussive slap when it strikes polished wood or stone, whereas woven cotton possesses inherent vibration dampening mechanics. The craftsmen optimized this acoustic advantage by employing Sashiko, a traditional running stitch that utilizes coarse, heavy cotton thread with a loose eat-whist construction, often 2 to 3 times the thickness of standard thread. This specific geometry creates a raised, heavily textured topographic matrix across the surface of the footwear, sitting proudly above the base fabric. When the foot moves through the air or brushes against an obstacle during the swing phase of a stride, it generates high-frequency sound waves, often peaking around the 2000 Hz range, which is the exact frequency of creaking timber and snapping twigs. The highly porous nature of the woven cotton and the tortuous internal path created by the thick Sashiko threads trap these acoustic waves. The friction between the vibrating air molecules and the loose cotton fibers forces a viscothermal dissipation, capturing the sound. The loose twist of the thread allows individual fibers to vibrate independently, converting the high-frequency acoustic energy into mechanical work and harmless, microscopic heat loss. The sound of the fabric rubbing against itself for the environment is literally swallowed by the material architecture. This mastery of material physics extended into the modern era with the creation of the Tabi, literally meaning tabi that touched the ground, which integrated a thin, vulcanized rubber sole directly onto the split toe upper. While traditional operatives relied on cloth, leather, or woven straw, the addition of a viscous stickle polymer perfected the erasure of the human sound wave. When a hard boot strikes a solid surface, the kinetic energy is reflected outward as structure-borne noise. The soft, elastomeric sole of the Tabi behaves fundamentally differently by physically stretching the duration of the impact. While a rigid heel strike in a modern boot might reach its peak force in 22.5 milliseconds, the soft sole geometry of the rubber eliminates this interaction to 26.6 milliseconds. This temporal stretching acts as a mechanical low-pass filter, rounding off the sharp acoustic spike and absorbing up to 3 joules of strain energy before it can radiate into the environment. The polymer chains within the rubber slide past one another in a state of viscous flow, absorbing the shock and preventing the sudden excitation of the floor's resonant frequencies. Furthermore, the specific geometry of the sole prevents the suction and release sounds typically generated by flat-bottomed shoes on smooth surfaces, maintaining a low-impedance interface that acts as a biological suspension system. Beyond the acoustic traps of the palace corridors lay the unpredictable, stochastic environment of the deep forest, where the threat is not engineered iron, but the brittle fracture mechanics of dry autumn leaves, dead twigs, and heterogeneous soil. A standard infantry boot acts exactly like a hydraulic press in this environment. When it descends, its broad, unyielding flat surface crushes the debris beneath it indiscriminately, causing thousands of rigid cellular structures to rupture simultaneously in a violent, high-frequency crack. To survive the acoustic nightmare of the forest floor, the Shinobi employed the koe-ashi, or small step. The foot is lifted abnormally high to clear any entangling brush, and the tip of the hallux is brought down completely vertical. The independent toe probes the cellular integrity of the debris beneath it. Only when the microscopic structure beneath the toe proves capable of holding weight without snapping does the rest of the foot slowly descend. The conformal geometry of the tab is soft sole plays a crucial role during this transfer of weight. Instead of crushing the forest debris against the hard earth, the flexible material deforms and wraps entirely around the irregular shapes of twigs and rocks. This envelopment dramatically increases the contact area, distributing the pressure outward and preventing the highly localized stress concentrations that trigger the brittle failure and snapping sounds of dry wood. By landing at a flat, 0-degree angle and a wide toe configuration. The practitioner maximizes the strain energy absorbed by the shoe itself, pulling the energy of the fracture up into the rubber rather than pushing it down into the earth. There is a severe, unavoidable physiological cost to this absolute silence. By deliberately stripping away the thick, cushioned heels, the rigid steel shanks, and the heavy impact protection of standard footwear to achieve an acoustic profile of nearly zero, the human body is left entirely exposed to the brutal reality of the terrain. The zero-drop geometry of the Tabi, where there is absolutely no elevation difference between the heel and the toe, forces the biological structures of the leg to absorb every fraction of kinetic energy generated by movement. The Achilles tendon and the plantar fascia are stretched to their limits, weaponized into primary biological shock absorbers. Without the artificial support and motion control of a modern boot, the practitioner must rely on perfect skeletal alignment, profound core stability, and the relentless engagement of intrinsic foot muscles to prevent structural collapse under load. One misstep on a jagged stone, a rusted nail, or a splintered piece of bamboo results in catastrophic, acute tissue damage, while the continuous lack of impact protection guarantees the chronic overload of the lower extremities. The tactical advantage of moving like a ghost through hostile territory is purchased directly with the accelerated degradation of the human spine and joints. The erasure of sound is not an act of magic or mysticism, but the cold, agonizing, and calculated manipulation of mass friction and kinetic transfer.